નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Standard 10th, Subject Science, Chapter 4, Carbon and its Compounds. So, dear students, in the first video, we have discussed some of the introduction and we have seen the ionic compounds properties and as well as carbon compounds properties. Okay, now today we'll see about the carbon, how it behaves. So you know that every element tried to attain the noble gas configurations. See, the reactivity of elements has their tendency to attain a completely filled with the outer shell. So in the octet form. So that is attain noble gas configuration. See, that also you learn elements forming ionic compounds. For example, sodium and chlorine achieve this either by gaining or losing the electrons from the outermost shell. The bond between these two, sodium and chlorine, so that is what the compound is formed, that is called as ionic compound. Okay, transfer of electrons. For example, I will show you sodium in its outermost shell, it will be 1 electrons, and chlorine, you know that. So like this. So it will be transferred like this. So sodium positive and chlorine negative. So like this way, sodium chloride formation forms. So this is ionic compound. So now what about the carbon? In the case of the carbon, so you know that carbon atomic number is 6. Say, carbon atomic number is 6. Okay. And you know that the electronic configuration is 2, the outermost orbit 4. In the case of carbon, it has 4 electrons in its outermost shell and needs to gain or lose 4 electrons to attain the noble gas configuration. Okay. But here, you know that for the carbon, it would be difficult for the nucleus with 6 proteins to hold on to 10 protons. Say, first condition is, say, for if it were to gain or lose electrons, so there are 2 conditions is given here. It could gain 4 electrons forming C4 negative NH. C4 negative NH. Say, for the carbon, you see that for the carbon, if it could gain means suppose C4. So gain will be there, negative charge, lose will be there, positive charge that you said. Suppose now in the outermost orbit 4 will be there. So here nucleus 6 protons, here 2, and here it will be 4. Okay. And if it gets 4 electrons again, so what happens? Total 10 electrons. Total it becomes 10 electrons. So, but it would be difficult for the nucleus with 6 protons. You know that here 6 protons will be there to hold the 10 electrons. To hold 10 electrons, it is difficult for the nucleus. So that is why it is 4 extra electrons is not possible. So that is why it could not gain the 4 electrons. So this is one condition. And second one, what happens? It would require a large amount of energy to remove the 4 electrons. You know that carbon is a small shell. See, carbon is a small shell. So you know that. So you go for here. Say nucleus, here 6 protons will be there. And here 2. And here it will be 4. So this positive and this electrons negative. See, carbon size is small. The force of the attraction between the nucleus positive charge and electron negative charge is very strong here. So that is why what would we require to remove the 4 electrons? To remove the 4 electrons, suppose here you know that 2 and 4. If you remove the 4 electrons, what will be there? It is only 2. So, so a large amount of energy to remove the 4 electrons leaving behind a carbon. So carbon with 6 protons its nucleus holding on just 2 electrons is not possible. So these are the two conditions. It is most important question. So why carbon will not gain or lose by gain or losing the electrons? So then how the carbon has to overcome this? So carbon overcome this problem by sharing its electrons, by sharing the electrons, valence electrons with other atoms of carbon or with atoms of other elements. So this is only we are saying the covalent bond, sharing pair of electrons. Okay, now not just carbon but many other elements are also form molecules. So they form molecules by sharing the electrons in this manner. So the shared electrons belonging to the outermost shells of both the atoms lead to both the atoms of the noble gas configurations before going to compounds of carbon. Now let us go for one example. For example, the simplest molecule formed in this that is hydrogen. So you will see about the hydrogen, you will see. So in this, how hydrogen covalent bond takes place. You know that hydrogen is outermost hydrogen atomic number is 1. So that is why it is not stable. So that is why in the environment it adds with other hydrogen and forms hydrogen molecules. Okay, hence then sometimes asking the question, draw the electron dot structure of a molecule of hydrogen. So you know that here, say suppose this is the hydrogen. Okay, we will go for electron dot structure, hydrogen, and here also hydrogen. Okay, so you know that 1 electrons and here also 1 electrons. So this hydrogen, 1 electron shares this. So in this way, making a bond. And this hydrogen also will make like this. Say hydrogen, so here 2. And now this hydrogen is also like this. So in this way here 1 bond is formed. So H bond H. So hydrogen molecule sequence. So this is the very important diagram. Draw the electron dot structure of hydrogen. So in this way you can show that. So you can use the dot structure. See, I am using the dot, or you can use the cross sign also. Okay, so like this way you can do this. Now another one is the shared pair of electrons. So in this way the shared pair of electrons is said to be or constitute a single covalent bond. So the shared pair of electron is called making the bond. So this bond is called as covalent bond, and the compound contains like this bond is called as covalent compounds. The compound formed by the covalent bond is called as covalent bonds. So covalent bond between the two hydrogen atoms, a single covalent bond is also represented by line between the two atoms. So line between the two atoms. Okay, so line between two atoms here also you can show. Now we will see about chlorine. So you know that chlorine atomic structure is 70. Say chlorine atomic number is 70. So 287. So electronic distribution is 287. So we'll see about the chlorine. Okay, 2, 4, 6, 7, and here also 2, 4. So like this and like this. So Cl bond Cl. So Cl2. So in this way, the atomic number of chlorine is 70. And what would be the electronic configuration and its valency? So 287 and valency is 1. Okay, chlorine forms a diatomic molecule. So can you show the electron dot structure? So this is the electron dot structure. And now we'll see the electron dot structure of oxygen. See, oxygen, you know that oxygen atomic number is how much? 8. So electronic configuration is 2 and 6. Okay. Now you see here oxygen and here also oxygen 2, 4, 6 and 2, 4, 6. So in this way and like this, so here double bond, oxygen makes a double bond and O2. So like this. See, in the case of oxygen, we see the formation of double bond, here on bond and here on bond. So oxygen bond, double bond with all this. So like this, oxygen makes this lead to be constituted double bond between the two atoms. Okay. Now the next one, can you now depict the molecule of water? See, molecule of water, how to represent? See, look here now. See, molecule of water, H2O, you know that. So H2O, and here O will make like this 2, 4, 5, 6, and here H and here H. So here cross sign and here also cross sign. So like this and like this. So then oxygen will be so like this. Okay. So in this way, 2, 4, 6 and 8. So like this 8 electrons. So this is the oxygen bond. So you know that. See, what is the bond? Oxygen, hydrogen bond, hydrogen bond. So like this way. So this is H2O. Okay, so like this way, you got the bond, say which one? Electron dot structure of water. So next one, we will go for methane. So methane very important. You see here, methane you see. The methane what? CH4 is the chemical formula is CH4. So see, okay, H and H and H and H. So okay, you can put the cross sign here. Okay. So like this way here and here and here and here. Then so like this. So this formation is, you see this one. So like this way. C bond here, H. So like this, CH4. So what? CH4. Okay. Now, see here, remember methane is very widely used as a fuel and is a major component of the biogas and compressed natural gas CNG. Its formula is CH4. Okay. And carbon achieved like this. See, carbon achieved like this, it got 8 electrons, total 10 electrons. See, that is why here carbon is tetravalent because it has 4 valence electrons and its valency is 4. So that's why in order to achieve the noble gas configuration, carbon shares these electrons with 4 atoms of hydrogen as shown in the figure here, and it shows the structure of neon. Okay, it shows the which one? Structure of okay, it shows the charge structure of the neon. So sometimes examination asking carbon shows the which one? Structure of which one? So carbon attains the noble gas configuration of neon. Okay. And such bonds are formed by the sharing of the electron bonds between the two atoms are known as covalent bonds. So this type of the pairs formed, say sharing of an electron pair between the two atoms are called as covalent bonds. Since the electrons are shared between the atoms and no charged particles, you know that ionic formation, charged particles are sharing, but here no charged particles are formed. So that is why such covalent bonds are generally poor conductors of electricity. So this gives rise to low melting and boiling points are also. Okay, these are the things you have to remember in this, the covalent bond, the properties and electron the dot structures of whatever we have discussed. Okay, and why carbon shows covalent bonds. So these are the important questions. So you have to remember this, and we will meet in the next video. Versatile nature of carbon. Okay, thank you. Bye bye. Thank you for joining us.